Hi, welcome to Redox Reactions Lesson 1. Any chemistry student will know that a central component of chemistry is the study of chemical reactions. The myriad of reactions can be classified into three classes: acid-base reactions, precipitation, and redox reactions. The redox reaction is a combination of reduction reaction and oxidation reaction. Some reactions, such as those in a battery, rely on loss and gain of electrons. The loss of electrons is the oxidation half of the reaction, and gain of electrons is the reduction half of the reaction. The two halves combined is the redox reaction. This is an example of a redox reaction. Here, iron, solid, will lose 2 electrons to become iron 2 plus aqueous, and copper 2 plus will gain 2 electrons to become copper solid. So the iron losing electron is the oxidation half, and the copper 2 plus gaining electron is the reduction half. The two half reactions combine to give you a redox reaction. The second thing I need you to know is that here, iron, which is oxidized, helped copper 2 plus get reduced. So iron is a reducing agent. This is the reducing agent. And by the same token, copper 2 plus helped iron get oxidized by accepting the electrons that it lost. So copper 2 plus is an oxidizing agent. It is very important for chemistry students to be able to identify quickly the species that is reduced, oxidized, and is a reducing agent and oxidizing agent. Luckily, we have a simple way of figuring this out by following what happens to oxidation numbers. The oxidation numbers are assigned to each element in a compound, and we follow what happens to the oxidation numbers in a reaction. I want you to pause the video now and take notes on the rules for determining the oxidation numbers. You'll need it. Now, for determining the oxidation numbers. Let's look at zinc chloride. To determine the oxidation numbers of each element, we know that we have a rule for halogen. We have a rule for group 7, halogen, which is assigned a -1. So we're good with chlorine. We can assign chlorine -1. You'll want to multiply the -1 with 2 and put it below. The other general rule is that the sum of the oxidation numbers for the atoms in a compound equals 0. The sum of the oxidation number values for the atoms in a polyatomic ion equals the ion charge. So this one, you need to put a number here, which if you combined with -2 must give you 0. So we know that this is +2. So the oxidation number of zinc in zinc chloride is +2. Let's try another. What about SO3? We have a rule for oxygen. It's here. The oxidation number for oxygen is -2, unless it's a peroxide, in which case it's a -1. So we have a value for oxygen. Multiply -2 by 3, put it directly below oxygen. Think of a number that when you combine with 6 will give you 0, because our rule says the sum of the oxidation number values for the atoms in a compound equals 0, unless it's a polyatomic ion, which means it'll be equal to the charge. So you and I both know that this is +6. Now, there's only one sulfur, so 6 divided by 1 is +6 again. So this is +6. Let's try this one. Scandium oxide. As before, we have a rule for oxygen, so we're good there. Negative 2 times 3 is negative 6. You'd want to put a positive 6 here so that they combine to make a 0 because scandium oxide is not a polyatomic ion. In this situation, you have 2 atoms, so that positive 6 is spread over 2 scandium atoms. So each one of those will have a positive 3 as the oxidation number. Gallium chloride. And I'd like you to pause the video and try it on your own. You have the rules with you. Okay, so did you decide that chlorine was negative 1? And negative 1 times 3 is negative 3. And because it's a neutral molecule, the sum of the oxidation numbers must add up to 0. So gallium gets a plus 3. There's only 1. So 3 divided by 1 is a plus 3. So that gets a plus 3. Pause your video again and try this one. Okay, did you realize that this is a polyatomic ion, so it won't add up to a 0? The rule tells us that oxygen is negative 2. So I want to put a negative 8 here. We do have a rule for hydrogen. And the rule for hydrogen is mostly positive 1, unless it's a hydride, in which case it'll be a negative 1. So this is a positive 1, so you get a positive 1 here. Now you want to think of a number that you're going to put here for phosphorus, and when you combine them, you must get a negative 2 as an answer because the charge is negative 2. So I think you'll agree that this will have to be plus 5, and phosphorus is plus 5. Pause your video again and try IF3. Okay, let's go ahead and look at this. We do have a rule for fluorine, which is negative 1 in all compounds. So we're good with fluorine. We have to give it a negative 1. Negative 1 times 3 is negative 3. We want the total to be 0. So iodine has to be positive 3. I want you to try this by yourself, H2SO4. We have a rule for hydrogen, plus 1. We have a rule for oxygen, minus 2. So we can go ahead and put a plus 1 here and a minus 2 here. 1 times 2 is 2. We don't know what sulfur is. Negative 2 times 4 is negative 8. We want the total to be 0. So sulfur will have to be plus 6. Pause your video and try Al2SO4 3. Okay, this one was a little tricky. I hope you realized that you do not have a rule for aluminum, nor do you have the rule for sulfur. You only have the rule for sulfate. The trick here is to take the sulfate out in its ionic form, and now you can figure out what sulfur is going to be. Oxygen, you do have a rule for oxygen, which is minus 2, so you get a negative 8 here. You can put something for sulfur as long as the total is negative 2, which is equal to the charge. And I think you'll agree that this is positive 6. So sulfur is plus 6. Now you do have a rule for oxygen, and sulfur is plus 6. We have altogether 12 oxygens here. 4 times 3 is 12. 12 times 2 is 24, so you have a negative 24 here. 6 times 3, you have 3 sulfur atoms, is 18, and it's positive 18. The total charge in aluminum sulfate is 0. So you can figure out what this number could be. Negative 24 plus 18 is negative 6. So you want to put a positive 6 here so that when you combine with negative 6, you get a 0. Positive 6 spread over 2 aluminum atoms will be plus 3 each. This is the last one, lead oxide, PbO. Pause your video and try it, please. Okay, this is an easy one because you do have a rule for oxygen, and there's only one oxygen, so this is negative 2. The total has to be 0, so lead gets a positive 2. There's only one lead, so you put a plus 2 on the top. Just to clarify, all the top numbers are the oxidation numbers that we follow in a reaction. Okay, this ends my video on assigning oxidation numbers. Hope this was helpful. I'll see you next time. Thank you. Goodbye.